Hello again everyone, welcome back to ptet.chemistry channel. This is the start of this section B for classification topic 10.2, which are just hydrocarbons in my classification, which includes alkanes and alkenes. In this last 10 questions of a Cambridge International Paper 1, it's typically these choosing from the three statements, whichever one is relevant to whatever is being asked. Option A is to do 1, 2, and 3, being whatever they ask. Option B is 1 and 2, relevant to what they ask, and C is 2 and 3, and option D refers to only statement 1 based on whatever they're asking you. Alright? So here, which pairs of compounds have the same empirical formula? So the definition of empirical formula is something that's stated in topic 1 under atoms, molecule, and stoichiometry, and you are supposed to have defined this in O-level as the simplest ratio of atoms, okay, in the compound. So if I look at option 2, I have ethene, which is C2H4, and I have cyclohexane, which is a cyclic alkane, cyclohexane, alright? So that's C6H12. The simplest ratio is CH2. The simplest ratio of the atoms, okay, you divide by 2 throughout, it's going to get 1 and 2. You divide by 6 throughout, you're going to get CH2 and CH2. They are the same. So the empirical formula is the same here, okay? If I then go for number 1, ethane, which is C2H6, and ethene, I can tell you already straight away number 1 is wrong because that simplest ratio is CH3. When you divide by 2, 6 divided by 2 gives you 3. The simplest ratio of the carbon and hydrogen there will be CH2, which are not the same. Okay, as you know, alkane and alkenes have different general formula. Their empirical formula are also different. 2 is correct, 1 is wrong. You only have one answer, which is 2 and 3. So that's option C. Of course, we can check for cyclohexane and oc-1-ene if you really want to. Okay, but I'm going to check it anyway. So cyclohexane, no need to check again. We already have it, CH2 just now. Based on this, it's the same, right? Okay, oc-1-ene, so it's an 8-carbon alkene. Okay, is an alkene, is CnH2n. So, you know, you could put in whatever n is and you're still going to have 2n. So what you're going to get is you're going to get CH2 anyway. Same like any alkene, CnH2n. Alright, so that's why number 3 is also correct. Moving on to the next question. So which compounds would be formed when you have ethene and aqueous bromine? Bromine is Br2. It's supposed to be pure, but you dissolve it in water. What you get is, you get a mixture. Okay? This reaction is called electrophilic addition. It's one of the key mechanisms in A-level chemistry. They do give you major and minor product. They proceed via a carbocation intermediate, and that is very important, especially in relation to this question, because this and this, they can compete as nucleophile based on the reaction mechanism. And again, to make it worse, in the presence of sodium chloride. So you're gonna have sodium chloride like that. And don't forget that when you draw the electronic configuration, if you show the dot and cross for chloride ion, you also have lone pairs on the chloride that can compete as the nucleophile. Okay, if I show using display formula, that will probably make more sense. My display formula haven't shown the 120-degree trigonal planar carbon sp2 hybridization at the alkene, but that's not important here. Okay, so when you have Br2 molecule, they get polarized by the double bond in such a way that rich in electron attacks the poor in electron, and then you break that. All of these are covered under the organic chemistry mechanism, which you can watch on my topical playlist under organic chemistry. Browse around, make sure you can master the mechanism completely, yeah? So this is the key step. You are producing a carbocation intermediate, okay? This is the one that I was just talking about. Very, very important. From here onward, what could happen is, you could think that you have that. It's the lone pair that will attack the carbon. Okay, so if I just show using that, then what you will get is you will get CHHBr, CHHBr. Okay, show from the lone pair to the carbon because you are forming that bond. that bromide has a lone pair and has a charge because you move the 2 electrons to the bromine, so you become an ion and you have lone pairs on the bromide that can do that. Okay, don't forget about the other things that are present. So the other thing that are present is H2O as well as sodium chloride. Okay, so just like you have bromide, of course you can also do the same thing with chloride, that is from the NaCl. Okay, so that could also do that. Of course, what I'm saying is they don't happen in one go, they compete. So what happened is you could also get this as the other product. All right, and of course last one would be the water acting as a, well, competing as a nucleophile as well. So if I show using black color, so you have 2 lone pair, you can use one of the lone pair to do that. Okay, competing, we talk about competing nucleophiles, and then you will get HCHBr, CHHOH. Okay, so it will have minus H plus at some point. Okay, and you get OH there. All right, so essentially what could happen is you can get bromine, chlorine, bromine, OH. Okay, so what have we got here? We got the I better change the color. We got the chlorine, which is impossible because you are not adding Cl2, and the first one that you add has to be delta plus, and you do not have chlorine plus. Okay, you have chlorine minus, okay, which is chloride, but you do not have chlorine plus, and you do not have Cl2. So number 1 is automatically wrong, which means there's only one answer, which is 2 and 3. Okay, I should have checked number 2 first, but I can spot the error straight away. 1 Br and 1 Cl is possible as a result of competing NaCl. Okay, so 2 is correct. They did not mention any of the product with OH in them, but this is also potentially one of the product with the competing water as a nucleophile. You can of course end up with 2 Br, where the bromide instead of the chloride just adds further. Okay, so there's 2 and 3 are correct, so that's option C. With this next question, so it's about catalytic cracking. So which compound can you get following the catalytic cracking of octane? So that is add carbon. So that is add carbon alkane, CnH2n plus 2. So what do we have? We have C8H, 8 times 2 is 16, 18, all right? So cracking is to do with break long chain hydrocarbon. Okay, so the definition, right? Break long chain hydrocarbon into smaller chain, or you try to branch it out. Okay, so straight away, if we just count the number of carbon, there's 1 carbon and 2 carbon. So 2 carbon. There's 1, 2, 3, and 4. There's 4 carbon. There is 1 carbon. There is 4 carbon, and there is 1 carbon. So altogether you get 4, 5, 6 carbon. Each of these are hydrocarbons with shorter chain than what you started with. Therefore, all of them are possible products from the cracking because you produce shorter chain hydrocarbons. Okay, so A must be the answer. Change to a better color. Which molecules will be present in the mixture produced by photochemical chlorination of methane? So we're dealing with free radical substitution because this reaction is photochemically induced. Okay, so I can't even spell substitution correctly. Substitution. Okay, so we are talking about the use of UV light, and in this case is chlorination, so we use Cl2, right? Would be present in the mixture. So if I talk about the initiation reactions, I'm going to talk a little bit about the mechanism, which is actually part of your case study, by the way. We use a half-headed fish hook arrow to represent this initiation step, which you produce the chlorine-free radical. And then your propagation steps actually begins with the CH form plus a chlorine radical. The chlorine radical abstracts another hydrogen and immediately it forms HCl, which means option 2 is actually correct, and you will get CH3 with a radical on carbon. But a propagation step means something plus something radical, something not radical plus radical give you radical plus not radical. Initiation is not radical, just forming radical. Okay, but propagation doesn't just doesn't stop there. It's called propagation because it keep on going on and on and on. In reality, you do not need a lot of chlorine radical because the reaction generate radical that reacts further with chlorine molecule. What you will get is you would substitute one of the hydrogen with chlorine, not in one go, but in stepwise manner. Okay, and then you will kick off more chlorine radical. And of course, this one can react more with this, or this one can react more with this, etc., etc. It's called a chain reaction for a reason, because you can't really stop at whatever you want. Okay, they're just quite difficult to control in reality. In terms of termination, many things could happen, one of which include the CH3 radical plus another chlorine radical give you the substituted product. But the difference between this being formed from termination step, this being formed from propagation step, is that radical plus radical recombine, no radical. Radical plus non-radical give you radical plus non-radical. Propagation versus termination, different, yeah? Of course, you could get many different type of propagation. You could get the two CH3 come together, etc., etc. You could get the two chlorine radical recombine to give you Cl2, entirely possible. Free radical substitution, anything could happen, but it has to be logical. You do not ever produce H2 gas, for example, okay? So here you do not ever, never, ever H dot naked, okay? What I mean by naked H radical is that the H dot radical will immediately form the HCl, and you do not ever get them isolated at all. So they do not go on and get formed like this. They do not go on and recombine like that, because you do not form a H radical in the first place. Okay, that's why you don't get hydrogen. 2 is correct, 1 is wrong. This is dichloromethane, so this is CH2Cl2. I have done one single substitution. If you react this with take out another H, you're gonna lose another H, and then you have radical. Then you attack another chlorine, you will have 2 chlorine and 2 hydrogen. 2 chlorine and 2 hydrogen. That's how you get dichloromethane. I leave that as a practice for you to do, to try and balance the equation and practice your mechanism. This is the last question of this 5-question series on introductory. This is not introductory, on these hydrocarbons, alkanes and alkenes. Yeah. So this is again about free radical substitution, but instead of methane, they are using ethane now. This is still chlorine. This is still using UV light, ultraviolet light. And what could happen is you have 4 carbon. This is an alkane. This is a 4-carbon alkane. And as you can imagine, this one could be produced from termination. So you say what may result, right? I'm just telling you that you could get it from termination, if I spell that correctly. Termination. All right, you could of course get CH3, CH2 radical. 2 of them recombine, and you will get CH3, CH2, CH2, CH3. Termination involve recombination of radical plus radical, give you non-radical. So 2 is entirely possible. This is just a single substitution product from ethane. You substitute a CH. You substitute a CH. So I could do a propagation, for example. Yeah. What was it I was going to do? CH2 dot plus Cl2. I mean, how do I get to this stage? You can look back at the previous question. To go to that stage, you need to react with the chlorine radical. You form the HCl, you get the radical on the carbon. Only then it reacts with the chlorine and give you your first substitution product, your mono substituted product. So this will have been come from Cl dot plus the ethane molecule, and then giving you this and HCl. But I'm just showing you the propagation. So there will be CH3, CH2, Cl plus that. So that is a propagation step. Of course, like in the previous question, you could also form it by the termination step. Okay, termination step involve radical recombine with radical. It doesn't matter if I put it on top or on the side. I'm just showing that it has one unpaired electron in reality. Okay. Next bit is, what is this? 1 carbon, 2 carbon, 3 carbon, 4 carbon. This is 4 carbon. What do we have here? CH3, CHCl, CHCl, CH3. Question is, can we get that? Can we get that? How do we get that? This is a difficult one. You can think about that. recombine with that. So we have to lose the H. Yes, we can, because once you form this, what could happen is, you see this? You already have one chlorine, right? Okay, so what happened is this thing can react with more chlorine radical, and then you will take out another H and give you HCl, and then it will create a radical there where they can recombine like that. So in fact, all three of them are possible. This last one is quite tricky for some students because they cannot relate it to one of the product which they can possibly form. Alright, this is the end of this 5-question tutorial series. I hope that was helpful. If it was helpful, please subscribe to the channel. Please share the channel widely with your friends, your class group chat, your juniors, your seniors from school, any 14 to 18 years old students, taking chemistry, as I do have GCSE and O-level topical playlists as well to assist those all the way from year 9 to year 13. Okay, thank you for watching. I'll see you in the next video.